I'm Anil Kumar. In this video, we'll discuss part 2 of the function f of x equals to x to the power of 1 over n, where n belongs to set of integers. We need to find domain and range of this function. Well, I never realized that this will become such an interesting question, and it will take 2 videos to explain. In part 1, we considered the function f of x equals to x to the power of 1 over n, where n was positive integer. So let me kind of give you in short what we learned there. So n we took as n as equals to 1. In that case, the function will be f of x equals to x, right? If n is 1, right? If I take n as equals to 2, then f of x will be equals to x to the power of 1 over 2, or you could say square root of x, right? Now, if I take n as equals to like 4, 6, and so on, it will be a series which will be similar to this. So it will be like 4th root of x and so on, correct? If n is odd, for example, if n is equals to 3, 5, 7 and all, then f of x will be equals to this like cube root, right? Or it could be the 5th root of this function. Now all these functions, we saw their graphs in the first part, and it was kind of like this. If for x, you know, the graph is straightforward. It is a straight line which divides like this, right? So this is kind of different from all others. It's just a straight line, and all those functions which are others. Now we can consider the function which is let's say even powers, n values even. If it is square root, then the function will be kind of like this. And if it is the 4th root, then in that case also the function will be kind of similar, right? So this will be when n is equals to even, right? And what we observed was that if n is odd, in that case the function will be kind of like this. This is when n is odd, right? For these roots. So that is how the function will be when n is positive for this given function. Is that okay? So that is how we saw it. So for odd, when n is odd, we found that the domain and range are, for odd, domain is x belongs to real numbers, and range is also, as you can see, y belongs to real numbers. However, when we have n is even, in that case, domain and range are x greater than or equal to 0, right? So the domain in this case is x is greater than or equal to 0, and range is y greater than or equal to 0, right? That is when it is even. Perfect. This is what we learned in part 1, right? So in short, this is what we learned in part 1. Now let's continue with this particular function. We can now take values of n which are negative. So if I write n as negative, let's say negative 1, so the first expression will be, if I write n equals to negative 1, what we get here is x to the power of, if n is negative 1, we get minus 1. That is the function we get, right? And if n is equals to, let's say, negative 2, what we get here is x to the power of negative, n is negative 2, so negative 1 over 2, right? So negative 1 over 2 is same as, let's say, function f of x is equals to, negative means 1 over, right? So it is 1 over square root x. Do you see that? So this happens when we have negative even powers. If n is equals to negative 3, in that case we'll have the function f of x equals to cube root, right? So 1 over. Is that okay? So that is going to be the function. Now let us see how these graphs will be. So the first graph is kind of simple. We have already done this. So I'll sketch a small one here. It is 1 over x, reciprocal function, and that's the graph. Is that okay? We discussed this in our first part also. Now let me consider these two graphs. When n is negative 2, or for that matter, it could be negative 4, negative 6. It will have kind of similar graphs. So let me do that here, slightly bigger than this, since that is the main objective of this particular video. So we'll discuss these two now. So let me make a line in between so that we use this space for the given discussion. Now if I have 1 over square root 2, how is it going to be my graph? Now square root 2 is always positive, correct? And 1 over square root 2. Normally the square root 2 function will be, so let me sketch the square root function first. It is going to be kind of like this. This is square root of x, right? Now reciprocal of this means 0 reciprocal is infinite. So that means we'll have a vertical asymptote here, right? We'll have a vertical asymptote here, and the function will be kind of decreasing. So it will be kind of like this. So that will be 1 over square root x, and this point will be at 1, 1, right? This point will be at 1, 1. So what you also saw that always the point 1, 1 is there on each and every graph which we have discussed so far, right? So that's a common point in each and every graph. So that becomes the graph for 1 over square root x. So this is the graph of 1 over square root x. Let me say this is 1 over square root x. Is it okay? Now let's look into the cube root. For cube root, the graph of cube root, let me sketch one, just as we sketched square root, it will be kind of like this and this. This is the graph of cube root of x. Now, how will its reciprocal look like? Reciprocal means small values reciprocal will be large, large values reciprocal will be small, and therefore this side will be similar to this, kind of like this, right? And how about this side? This is negative. Reciprocal of negative will be negative, so what we expect here is also kind of like this. So it's kind of similar to this. This is also odd, this is also odd, and that's how it is going to be. And these points, as you know, will be 1, 1 or minus 1, minus 1. Perfect. Or 1, 1, correct? So that is how the graph of odd powers will be. So I can say safely that if n is equals to negative 2 times some number, right? In that case, domain of the function is going to be x is greater than 0. It cannot be 0, right? And the range will be y is also greater than 0. But if n is odd, that is, we are saying negative in odd. So negative, let's say it is 2 times n plus 1. That ensures that it is odd, minus of 2 times n minus 1. In that case, the domain will be all real numbers, right? So x is not equal to 0. It could be anything else, but not 0. And as far as the range is concerned, y is not equal to 0, right? So I hope with this, we can conclude that the graphs of x to the power of 1 over n for different values of n will be, if n is positive, it will be something like this. However, if it is negative, then it will be something like this. We are still left with two graphs, two different values. N is all integers, right? So what happens when n is 0 or when n is infinity, right? So we can conclude it here. So we'll take two cases now. First, when n is 0. If n is 0, then we have f of x equals to x to the power of 1 over 0. Now that is infinitely large. This is like x to the power of infinity. So x to the power of infinity will be a very, very large value. So this is a very, very large value, right? However, if n is equals to infinity, a very large number itself, in that case, f of x equals to x to the power of 1 over infinity, and 1 over infinity is 0. It will be x to the power of 0, and that should give you 1. So f of x is 1 if n is very large. So 1 basically means that it is going to be a constant one, a horizontal line. Do you see that? So it'll be a horizontal line. So for n equals to 1, let me draw one here. We could draw anywhere. Let's do it on this side. So we have n equals to 1 will be a horizontal line, right? So it is for n equals to 1. In that case, I mean n equals to, I should say y equals to 1, y equals to 1 when n equals to infinity. When n equals to infinity, we have a horizontal line which will go through 1, as we've shown here, right? So n could approach very high value. In that case, what we will observe is that it will be kind of a horizontal line. 1 to the anything to the power of 0 is 1, right? So the value will be constant for each and every value of x, right? So that is the case. So I hope with this we conclude for all integer values of n, the function f of x equals to x to the power of 1 over n will be one of these kinds. I'm Anil Kumar, and I hope you find it very interesting. You can always share and subscribe to my videos, and if you like, you can put some likes. Thank you, and all the best.